If you're still watching the sky for your packages, you're waiting on a promise physics quietly broke. Break time equals 0. 6 is slash 15 minutes, £5, 1 FAA rule. The escape route comes last. Here's what really grounded them. Amazon promised 30-minute drone delivery back in 2013. A decade and billions of dollars later, almost nobody gets packages by air. This is why it matters. It's a clean case study in how physics and regulation, not hype, decide what technology actually ships. The fix here isn't better marketing. It's simpler, and almost nobody in the hype cycle admits it. That's last. Start with the battery, the thing everything else hangs on. Here's the hard number. A pound of lithium battery stores roughly 40 times less usable energy than a pound of jet fuel. So most of a drone's lifting power goes to carrying its own power. Think about that. The engine is hauling its own gas tank, and the gas tank is most of the weight. That's the trap at the center of this whole story. Now stack a round trip on top. The drone flies out, hovers to lower a box, then flies all the way back to the depot to recharge. And hovering is the single most expensive thing a drone does, because fighting gravity in place drains the pack fast. Do the math on out 10 back plus a hover, and the practical delivery radius lands at only a few miles from the depot. Not a city, a neighborhood. And it gets worse over time. Cold weather saps how much charge a battery holds. Heat degrades it faster. In every single charge cycle, the drone might fly dozens a day, wears the pack down a little more. So the range that was already small keeps shrinking across the fleet's life. The battery doesn't just limit the drone on day one. It limits it, then quietly gets worse. Which is exactly why the old fix, just add a bigger battery, backfires. Here's what that bigger battery actually does. So they cap the weight instead. Most delivery drones top out around 5 pounds of cargo. That's the ceiling industry-wide. And here's the problem that number creates. A huge share of what people actually order online weighs more than that. A case of water, a pair of boots in the box, a bag of dog food, all grounded. Now why 5 pounds and not 50? This is the weight spiral, and it's the mechanism that traps the whole design. Carry a heavier box and you need bigger motors to lift it. Bigger motors pull more power, so you need a bigger battery. But a bigger battery is itself heavy, which means you need even bigger motors to carry that. Every pound of cargo you add demands more than a pound of drone to haul it. The design eats itself, and it eats itself before you ever reach the weight of a normal order. So picture what 5 pounds really buys you. A phone in a padded envelope, sure. A paperback, a small bottle of pills, genuinely useful for a sliver of orders. But hold that against a typical Amazon box. The multi-item order, the household restock, the thing with actual weight, and the drone simply can't take it. It's not a software update away. It's arithmetic. And arithmetic doesn't care about a press release. Even a light box, though, still has to survive the trip out. That's where the sky itself becomes the enemy. Here's the part the demo videos never show you. The weather. A delivery van drives through rain, cold, and a stiff breeze without a second thought. A small drone doesn't get that luxury. Moderate wind, steady rain, a cold snap. Any one of them can ground the fleet for the day. And it's not just that flying gets risky. A lightweight airframe fighting a gust has to burn extra battery just to hold its line. So the range that was already only a few miles shrinks even further on exactly the days you'd most want a delivery. The wind literally eats the miles. But the deeper problem isn't any single storm. It's reliability. Think about what you actually need from a delivery service. It has to work on the bad days too, not just the calm sunny ones. A service that folds the moment the forecast turns can't be your main way of getting packages. It can only ever be a nice weather bonus riding on top of the trucks that were going to come anyway. And a bonus doesn't replace the fleet. It just adds cost. That's the quiet killer here. Not one dramatic crash, just a system that can't promise Tuesday when Tuesday is windy. Which brings us to the limit that had nothing to do with weather or batteries or weight at all. And it's the one that actually kept the fleets on the ground. Now the one rules. The thing that mattered more than any battery. For most of this decade, US aviation regulators required a human to keep physical eyes on each drone the entire flight. Fly a drone past the point where a spotter can see it, and you're doing what's called flying beyond visual line of sight. For years, that needed a special waiver. And mostly it just wasn't allowed. Break time equals 0, 6 is slash sit with what that means for the money. If every drone needs its own human watching it, then you haven't automated delivery at all. You've hired a person per package and handed them a drone instead of a van. The whole promise was cutting the driver out of the loop. This rule quietly put a driver back in. One per drone standing in a field staring at the sky. Try to scale that to the millions of packages a real delivery network moves in a day, and the payroll alone buries you. The economics never even get to close. And the waivers that would relax the rule came slowly, case by case, region by region. A trickle, not a green light. So here's the honest ranking. The batteries were a wall. The payload was a wall. The weather was a wall. But this rule was the ceiling over all of it. The single limit that, more than any law of physics, kept the fleets from ever scaling up. Which is why the verdict is more interesting than just failed. Here's the resolution, and it's the part almost nobody says out loud. None of these four was fatal on its own. Batteries improve. Payloads creep up. Weather rules loosen. Any single wall you could climb. The problem is they don't come one at a time. Stack them, short range, a 5-pound cap with a grounding and 1 human per drone. And the math against a van driver never closes. The van already exists. It already drives your street. It carries 50 pounds in the rain for the price of gas. That's the bar, and drones kept missing it on 4 axes at once. So where do drones actually work? Exactly where those trade-offs flip. Rural medical delivery. A blood sample, a defibrillator, a snakebite antivenom flown over a mountain a van would need 2 hours to reach. Remote islands. Places where the cargo is light, urgent, and high value, and where there's no van to beat. That's the doable truth to hold on to. It wasn't a failure of ambition. Engineers didn't dream too small. It was a failure of energy density and airspace law. 2 things a pitch deck can't fix. Judge the tech by the physics, not the promise, and you'll see the next one coming. So that's the whole cage. Short range, a 5-pound payload with a grounding. And above them all, the one rule that put a human back on every drone. 4 forces and a ceiling. Next, we open the door the other way. What would actually have to change? Denser batteries or a real rollout of beyond line-of-sight flying? For a drone to finally drop a box on your porch. That one's the offense.